Hello, StarkNet family. Welcome back to the Star Cafe. I'm Nurstar, your personal Star barista. And once again, we are ready to serve you with some very special StarkNet content. Hello, everybody. I wish you all a very good start in the week. And today we are going to focus on storage proofs, which are one of the most promising and interesting primitives that are being experimented and developed on StarkNet. And in order to speak about storage proofs, we have the pleasure to host Pia Park, a very active contributors in the StarkNet community. She contributed to many open source projects such as Madara, the StarkNet sequencer, and Tsubasa, uh, um, uh, um, a gaming project, open source gaming project. And today with her, we are going to speak about storage proofs, what they are, first with a simple definition for also for people who are not technical, and then we are going deeper, we're going to get deeper into the tech and discover how Herodotus Turbo works, and also the latest implementation of at Herodotus. And having said that, let's welcome her. Hello, Pia. How are you? Hello, Pia. Welcome back.
Oh, sorry. Now it's mobile. Like
No
I
worries.
find out the if I access to the laptop, it keep like makes me into listener again.
I see. Yeah, that's why I told you better join by mobile because normally it doesn't let you speak from a laptop. Anyway, after give you the introduction for a couple of times, let's go straight to the topic of today. And would you like to tell us a bit about your background and also how did you begin building on StarkNet? And also you can also mention some of the very precious open source contributions that you made in the space.
Yeah, sure. I've been started to like code since like when I was like 2020 year, and after that I met the crypto, and then I was interested in like building the crypto related like communities, etc. And then I figure out, oh, the technology itself is evolving very fast, so better to like just jump into the like projects like with the hackathons, etc. So I started to like do the hackathon travel like since this year. And while doing like hackathon traveling, I built some like projects that handles the cross-chain narrative and like zk related projects like during the hackathon. And then um, I joined Herodotus, like because what they're building was what I'm actually really interested in, and I'm passionate about like this crypto technology industry. And yeah, after I joined, because Herodotus made a product first, like, they launched a product first on the Starknet, so that naturally like lead me to interested in the Starknet ecosystem. And then I figure out there's some like lot of like infrastructures or infrastructure projects that like the Madara like Starknet sequencers and like Dojo's game engine, and which handles a lot of like blockchain technology like infrastructure side like perspectives. And I started to like like deep into the rabbit hole. And I love to like learn Rust. I love to learn Cairo. And I started to contribute on the projects that the new you just mentioned about, like Madara, Kakaro Dojo, Cairo book, and etc. And and while doing it, I'm keep learning like more about like how to storage proof can be as in a use case or like potential for like future like crypto like technologies. So that's my story, kind of.
And it is a very interesting one. Thanks a lot for sharing it. And let's start speaking about storage proofs. So let's begin with a simple definition about what storage proofs are. So could you explain to us what they are, and what are what is the main characteristics of storage proofs, and what kind of problems they solve in the space? So obviously, as a non-technical person, I heard when I started hearing about storage proofs, so my first impression is that we are talking about a kind of bridging tech, right? So like a tech that helps transferring data and eventually assets, maybe if I'm not wrong, from one chain to the other one, right?
Yeah, it's you can see the very famous meme like about the Herodotus, which is like bridging states everywhere. It's like storage proof. Like recently, like Stocknet, Twitter also like mentioned about this meme. So as in maybe like non-technical like public to the non-technical public, it's same as bridging bridging means that you can access from one to another, right? And you can basically access the state, which is blockchain informations, to one chain to another chain. And how does this can be possible? The background is we're using the technology named the storage proof. So you can just easily think that we are building, and the technology that we are using is the layer to read the blockchains, like especially Ethereum based blockchains.
Very good. For those interested, I'm going to post in the comment section the meme that the meme that Pia mentioned about storage proofs. And I also made a very fun meme about storage proofs some months ago with a video, but I don't know if I'll manage to get it back, featuring Marcello, one of the
Uh,
founders of Herodotus. Yeah. And anyway, memes aside, thanks a lot for this very easy to understand definition. And let's get a bit deeper into the details on how storage proofs work. And could you explain to us how these storage proofs work a bit more in the technical details for the more technical audience?
Sure. So if you maybe think of the definition about the storage proof more accurately, then the storage proof is not like new concept. Like you can get the proof from the like RPC, the each get proof method, and if you get that, then you can get the proof that certain value is stored in the storage. Like you can get the proof of is this value is stored in this storage or not. So maybe you like the reason why we like always like trying to explain the storage proof, then we definitely need to explain the how does the Ethereum is like constructed, because storage proof itself is we are storing some data like maybe token balance or like NFT informations or like account notes and like balance, etc. We're storing this kind of all the information inside the block, which is like some sort of storage. Maybe you guys might heard of it, like we store the data structure named Marco Patricia tree, and there's a proof. You can actually generate the proof based on is this data that I just mentioned is actually stored inside this storage or not. So that's the technical definition, like technical explanation about the storage proof. So okay, then maybe this concept is not new. Then what do Herodotus like, and how do we leverage this storage proof to bridging states everywhere? Is we're using the ZK proof to wrap the storage proof, and then we verify from one chain to another chain. So which means if you verify the ZK snark proof, the reason why we're using ZK snark is because storage proof itself is pretty huge. So if you want to actually use it as a developer, then you have to make the proof size smaller. So that's why we are wrapping the ZK snark to the storage proof. So first step, you verify the ZK snark, and then inside the storage proof itself will point out this value is exist or not in one chain, and you're verifying in other chain. So to wrap it up, it means we're using the multiple, like using the different type of proofs to verify the certain. Verify means you're reading it to read the certain value that you want to get from one chain, like um, for example Ethereum, to other chain, for example like Starknet. Yeah.
Very good. And what did you describe? It is for example, you launched the Herodotus Turbo product during the last Starknet CC in Paris, and this kind of process that you just described. Can we connect it to the Herodotus Turbo product, or it is just the underlying process of storage proofs?
Oh, okay. So actually, all of the proof generations that I just mentioned is anyone can do it. But the thing is, we're using a lot of like optimization on the background. So we will like what we are providing to the user is the first of all API, which is already launched on the like Starknet and zkSync. So what this our API is doing on the background is exactly the same process that I just mentioned, and exactly the same process, and we're adding some like more technical stuff or services to make this they make this information or data is actually secure or um, like fast to deliver to other chain. And so basically what we have already is API. So what is the turbo is because our API is only like supporting to generate the proof of the basic stuff like account access, um, block header access, like transaction receipt access, etc. Um, Actually, what you think of the use case is you might need to get the proof of specific value that's stored inside the smart contract. Um, to give you an example is if you think of the ERC20 token that deployed on certain smart contract, then the token balance is actually written inside the smart contract of that ERC20 token. So if you want to get this kind of information, which is like custom information, then you need to calculate the storage slot that where this specific value is stored inside the smart contract. And right now, our API is like only handles to generate the proof of the storage hash, which means um, the root of this storage. And what user have to do to developer have to do is they have to calculate the storage slot by themselves. So our turbo is the interface of the API so that people don't need to like think about this kind of very like maybe yeah, turbo is basically the interface of the API that enhance the developer experience. And then the historical Ethereum proving system that we announced at the Starknet Summit is allow user that we're just proving the whole blockchain of the Ethereum L1 from Genesis to latest block. Why this amazing is because you can actually retrieve the block from the latest block, but there's a limitation of the 250 like ish. And what we developed is we based on the recursive proof of the block header. You can like skip this kind of like technical stuff, but based on the recursive proof, you can able what we are able to prove the whole blockchain, like the of the Ethereum from the Genesis block to the latest block, so that user want to call the user want to read the data stored inside the very old historical block, like near to the Genesis block or something, they can able to retrieve the data from it from our product.
Very well, Pia. Thanks a lot for that. So, if I've understood right, Turbo is a kind of the interface, an interface, sorry, where you can leverage storage proofs and use storage proofs. Meanwhile, the latest, the historical data transferring regarding the Ethereum's history. It is a use cases, right, where you can basically verify data from any point in Ethereum's history. And so now it's much clearer to me as well. And could you also mention some other practical use cases that are being experimented with storage proofs? I know that you played a bit with storage proofs during the latest Starknet Summit by working on that was in June actually, when you worked on the Stark badge. If I remember well, it was in the Korean blockchain week or something like that. And you developed this project called Stark Batch. And then I also saw that other projects such as Pragma X are using Herodotus Turbo for their own products. So yeah, could you go a bit further down the use cases that are being experimented using storage proofs, please?
Oh, okay, sure. So, what can be powerful is if you want to read the historical data, which means like very old data, like I mean, we can actually access to the data through the like archive node or the RPC, but it's the information is centralized and we have to trust them. So using Herodotus, first, if you want to retrieve the data from the historical data, which is old data, what can be the use case for this is maybe the um, account inactivity. So what is account inactivity means? If you think of your like gaming with just normal Web2 gaming platform, or the just like normal Web2 platform, if you register your account and then if you're not using your account for like certain period of time, like 2 years, 3 years, then they actually like transfer the ownership or make the account inactive, right? And right now, what the crypto wallet, like it's really hard to like calculate the account inactivity, but but you can actually compare the nonce, which is nonce means if you make a transaction of the account, then your nonce will increase. So that means if you if your nonce is same for a certain period of time, that means you didn't use your wallet for that certain period of time, right? So what I think in Lisbon, I make a POC of the project or wallet inactivity, which is you compare the nodes between two block numbers, and if the two nodes is same, then you can consider this as an inactive account, and you can like transfer the ownership to the master account or something. Okay, this is the one example, and then the Stark batch that you mentioned is basically I want to like show the how powerful the storage proof can be when you want to breach the state everywhere, literally the meme. So what this project did is bridge the ownership of the NFT to anywhere, which means you bridge means your EverAI NFT is deployed on the Ethereum, and you bridge this ownership. Hey, I have this EverAI at block number like 10, and you bridge it to the Starknet. And what I add is NFT mirroring concept. So you can verify that you own the NFT in the Ethereum at certain block number, and then you mint the new Starknet NFT that reflects this ownership. Yeah, so I thought this NFT mirroring can be used in more informations, more use cases, like if you want to maybe to like filter the users based on do they hold this NFT in certain block number, then you can check if they have this NFT, a mirrored NFT in the Starknet, and then they can do it. Or you can use as a like gaming, like if your asset is deployed on the Ethereum and your game is running on the Starknet, and you can also use this kind of same experience. Yeah, I think I post one like thing that like a list of the use cases that we are working on, and we will update the use case page of our docs, which is first is like using Herodotus to read L1 balance from L2, and like second one is like you can do the cross roll up ENS resolution. And recently I post the how do autonomous world with the storage proof can be give some potential. And then yeah, I just mentioned about the region historical data, and you can actually access the Rendau parameter. Rendau is the like a fully like the value that gives the fully randomness in real time of the Ethereum block. And right now Starknet don't have a like native randomness value, so yeah, using Herodotus you can access the Rendau param on the Starknet, and also like you can use as a cross-chain governance, insurance, yeah, etc.
Very interesting, Pia. I really like the part about NFT mirroring, because I also think that it is a way to also remove security risks, because the NFTs will remain in the Ethereum L1. So no matter what happens in the L2, right, or during the bridging phase, the NFT will always be secured by the L1. And I also find this feature very powerful for gaming. And you recently wrote a very interesting thread about use cases of storage proofs being implemented on gaming. And I attached that thread to the comment section below this space, where you also find other interesting information and memes about Herodotus, included the GitHub repo about Stark Badge as well. So have a look at the comments. And having said that, Pia, um, uh, like how does the future of storage proofs look like? Are you working on something else at Herodotus? Are you able to spoiler something, or like you can say anything?
uh I mean, right now I'm like, while contributing to the like Starknet ecosystem, I got interested in like Rust, and then yeah, Cairo, and then low level like system programming. And we have a service that generates the like MMR, compute C MMR with the Rust. So I'm basically right now like working on this to make more optimized. And yeah, this is like a one of the tech stack. And apart from that, we are basically the whole team is preparing for the big release, which is we are going on the mainnet soon. And uh, like our architecture has been a lot optimized and a lot changed from the architecture that on the document that right now. So our our website and our documentation and the architecture will be renewed soon, while when the mainnet's launching. So I think that's the very excited part. And yeah, and also like Turbo Stack is what we announced at the ACC is more like a explanation how the architecture will look like. And we are working on the Turbo to make it happen. So like soon the project, if they want to connect the um Herodotus product, then you no longer connect to the Herodotus API and have to like recalculate the storage slot by your own selves, like I just mentioned, you can just make a one line of simple cross-chain query, and then you can get the value that any chain that you want.
Awesome. Really looking forward to seeing storage proofs being deployed on mainnet and unlocking all their amazing potential. And well, we are coming to the end of this episode, but I would like to thank all the listeners for coming here. And let me know, guys, if you would like to ask Pia for a question about storage proofs. We'll be waiting for 20 seconds or so. So feel free to either write something on the comment section or to send us the request to speak, and I'll be glad to grant it to you. So yeah, in the meanwhile, Pia, I saw that you went to a lot of hackathons recently. Which is your next hackathon?
Oh, uh, actually, like hackathon is very good for exploring the like recent like technologies and meeting people to like expand. And I'm now in the phase that I want to like focus more on like what I want to be good at, and so I'll have a like lot of term to go next. So I'll probably go to the next conference as in like Dev Connect. But right now, um, I'm in the Mute Chiang Mai, which is a hacker house that organized by the Mu like organization. And yeah, I think these two will be my like uh few months like plan for maybe hackathon. Yeah.
Yeah, it looks like a very good plan. And yeah, for those who don't know it, the Mu initiative in Chiang Mai in Thailand, it is a sort of Juzalu initiative, which is also sponsored by Starkware. And yeah, there are a lot of workshops and hackathon and an hackathon going on. And yeah, it is an initiative to brainstorm potential around these technologies. And yeah, I'm glad to know that you're also there, Pia. Send our greetings to all the Starknet crew. And yeah, I see that there are no questions so far. So yeah, thanks a lot, Pia, for coming to the Star Cafe. I hope you enjoyed it, and really looking forward to having you back in the near future. Maybe once the storage proofs will be running at full speed on mainnet, and I'm sure we'll be witnessing a lot of very interesting use cases being experimented through storage proofs, and I'm really excited about that. Thanks a lot, Pia.
Thank you for invite, New Star.
It's been a pleasure, and thanks a lot to all the live listeners and to all the replay listeners. It's been a pleasure to have you here. Thanks a lot for your time. And yeah, it's now time to close the Star Cafe. See you next time, and remember to share the Starknet vibe. See you guys. Take care. Bye.
Thank you.
Bye bye. Bye, Pia.